अरे तुम्हारी क्लास में कितने बच्चे आए थे आज? I hope I'm audible to all of you. Okay, so let us start it. It's 11:27. I'll directly start at 11:30. My voice is audible. Camera is on. Yes. Let me spotlight it for everyone. Yes. Let this camera be here on the top. And let us start our lecture. No, don't unmute yourself, okay? Don't do this. See, today we'll be starting our 12th session, first chapter, that is electrostatics. Okay? So you are going in a like, I hope that you're excited for this new chapter. So let's start it. It's very interesting. Students, it's very, very interesting. Very, very interesting. Very, very, very much interesting. At 11:30, I will directly start. I will not wait. Why the students are less? I have to text here. Students, join. Can't you see? At least join for a few minutes. I need. Okay, so let us start it. I'm launching a poll for all of you. Okay? Please participate in this poll. Technical poll I have launched. Please participate in this. Am I audible? And is the screen visible to all of you or not?
Yes, sir.
Yeah, very good, very good. So you can respond in the class in the beginning, okay? Participate in this poll, please. Okay, we'll start at 11:30. So it's time to start. Apurva se participated, sir. Very good, very good. Yeah, Apurva, you are having some doubts, so I'll clear your doubt at the end of the class. Okay. So if anybody else is having a doubt in any of the topic, okay, so you can ask it at the end of the class. Okay. Participate in this fast. So I'm recording it. Record to the cloud. Recording is started. Yeah, all of you have joined. It's good. Yes. Yes. Okay, very good. All of you participate, please. Sir, no doubt. Okay, very good. No doubt, no issues. All of you must participate in this. It's very important chapter. So today we'll be starting a very fresh chapter, that is electrostatics. Okay. Yes, participated. Okay, I'm ending the poll. ठीक है. Okay, students. So here we go. Recording is also working now. Yeah. See, so what are our learning objectives for today's class? Okay. So see, yesterday I have told you about the gravitation and electrostatics, that how the gravitational formulas are interconnected with the electrostatics. I've told you this thing. What I told, if you have studied your gravitation chapter in the 11th class, how that chapter is interconnected with this 12th class chapter, that is electrostatics. Okay, the formulas are same. You just have to, what we have discussed the previous class, we have discussed this thing, that what you have to do is this, you just replace the G in the formulas of gravitation chapter with this K, and charges, sorry, the masses. I must write here the masses. And the masses you need to replace with what? किसके साथ करना है? Charge. ठीक है? Students, please don't make noise. You can keep with you the notebook and the pen and the paper, whatever. Okay, so make the proper notes. This is a complete class. I will explain you all the topics, all the theory from the deep. Okay, from the beginning, from basic. Okay, so these are the learning objectives. First, we'll go through that. We'll understand what is this electric charge. Although I have given you the glimpse of this, that what is an electric charge, by the way. Okay, so first we'll go through this electric charge. Then we'll understand what is this Coulomb's law. So also we have seen somewhat that when two charges are present, there is a force of either attraction or repulsion between them. And this is given by some mathematical equation, which is known as Coulomb's law. Okay. Then we'll understand what is this electric field. You will understand this thing. Okay. After this electric dipole. So I think today we can at least cover these two, electric charges and Coulomb's law, or maybe the electric field. So for the next session, these topics are remaining, that is electric dipole, flux, continuous charge distribution, Gauss laws, and its application. You will find this, and you may find this in several books or several modules, that Gauss's law and its applications fall under the category of electrostatics too. Okay, this fall under the category of what? Electrostatics too. Remember, starting from the electric charge and electric dipole to, yeah, this also falls under electrostatics too. So this comes under the part of electrostatics 1. So these are basic segregations depending upon this electric flux topic. So when the electric flux topic is initiated or taught in the class, it is taught in a separate module, separate sheet, even in the branded institute in Kota like this. Okay, it falls under electrostatics 2. So up to here it is cleared. So you can note down your topics in your notebook. So now we are starting with electrostatics 1. Okay, and we'll start electrostatics 2 maybe in the next or the third week. We'll see what to do. So this is electrostatics 1. Note down the topics. We'll study in this electrostatics 1, electric charge, Coulomb's law, electric field, and electric dipole, up to this much. Today we'll try to cover 2 of the 3 topics from the beginning of this objective. Okay? Please note it down. I'm giving you a few seconds to note it down. Please note it down. Okay. Have you written this thing? Let us proceed next. Text me in the chat box. Have you written this thing? Yes or no? Reply me in the chat box. Okay, very good. You have replied it. Very good. Vikas says yes. Pradeep says yes. Very good, students. Okay. So next this. Very good. Very good. Okay. So see, I think you're able to see this picture. What is happening to this boy? I hope you're able to see this picture. What is happening to this boy? Can anybody say what is happening? Any one of you? Just hold on. Some students are saying me, sir, we are not having this Zoom credentials with us. So let me print screen with this thing. And this is the ID. Just hold on 1 second, students. Let me send this to this group. Okay, now it's fine. Now it will be easy for you to connect. Okay. Now, students, it will be easy for you to connect. So if you're not able to connect through the link, connect through this. Okay. So let us see this. What is happening to this boy? You know, the charges are getting transferred. Okay. And you can see, you can think like this, that on the air, the charges are what? Like opposite charges. If it is negative, so the charges on the individual here are what? Negative, negative, and negative. So we have seen in the previous class, if the charges are negative, that is same nature. Also, if the charges are positive, that is again the same nature. So if the nature of the charges are same, that is same nature charges, so they will what? They will repel each other. There will be what? Repulsion. If the nature of the charges is same, there will be what? There will be repulsion here. Okay, fine. Let us proceed next. So if you see here, you can do this experiment. Okay. So what you do is this. Rub a ruler. Suppose this is a ruler. This is what? Ruler. Ruler matlab scale. Yeah, your geometry box scale. Okay. Suppose you are having a ruler with you. You rub this ruler. Somebody have texted me something. Written. Okay, very good. Suppose you rub this ruler with your hairs or somewhat some cloth, silk cloth. Okay, it's Mysore. You're having a lot of silk. So rub with the silk cloth and then bring this ruler near this water which is flowing from a tap. Okay, so what you will feel is this, that this water, okay, it will get fluctuate at a point. Suppose if I'm bringing this ruler at this point, you will find the path of the flowing of this fluid. Okay, it will get deflect, it will get fluctuate. So why it's happening? Because when you rub this ruler with your hairs or silk, whatever, it gains what? Either it will take positive, depends upon hairs and silk material, or either it will get positive or negative. So what's going to happen when you bring this ruler near to it? So this water is also having the same like charges, maybe positive, negative. So when the positive is here and the ruler may be positive here, so what's going to happen? This will repel. That's why the path is deflected. Or we can say if the fluid is having negative charges here and the ruler is also having the negative charges here, so what's going to happen? Again, the path is deflected because we already know the statement. What we knew about the statement? That like charges repel each other. Like charges repel each other. That is, it may be negative, negative. It may be positive and positive. Okay. I hope it's clear. Let us move next. Clear ho gaya yahan tak? Please reply in the chat box fast. Interaction is very important. Okay. Please reply in the chat box. Please, students, reply in the chat box. Interaction is very important. Okay, very good. One of the student, intelligent student have texted Vikas, Pradeep, Punyashri. Very good, very good. Okay. So you must reply in the chat box. Otherwise, so till now the session is going on very smooth. We just seen the charges somewhat and some real life examples of the charges. Okay. Let us see next. So see, you can see the video, what is happening. I will launch the video for you. Let me remove the annotations for you again. So see what is happening. Isn't it good? So it's all about science of charges. Okay. So you can see when this person, So when this person is bringing this ruler near to it, what is happening? Fluctuation is happening. You know? So how the water is, what tap water is deflecting, you can see with your eyes. So this is all due to, here it is attraction. So we will comment like this, इस पे positive charges हैं और इस पे negative charges हैं. ठीक है? So when this ruler is brought near to this tap water, what is happening? Unlike charges will attract each other. Agar if is dono pe, if on both of this the charges are like, so they will repel. So tap water will not fluctuate like this. Fluid will not be turned like this, but the trajectory of the fluid will be like this. Okay, I hope it's clear. I hope students it's clear. Let us move next. So what about this fabric cloth? Now see proper. There's a balloon and a fabric woolen cloth and the shreds of paper. Okay. Suppose I rub this balloon with this woolen cloth. When I'm rubbing this balloon with this woolen cloth, what's going to happen? It will gain some opposite charges. So when I bring near to the paper, shreds of paper get what? Attract to this balloon. Why? Can anybody explain? I want the explanation in the chat box, students. It's a very, it's very interesting video. I hope you all have enjoyed this. Let me show you again. So woolen cloth, fabric woolen cloth, balloon, okay, shreds of paper, inflated, okay. So when I'm rubbing this balloon with this woolen cloth, is pe charges aa gaye hain, which is opposite to the charges present on this paper. So when I'm bringing this balloon on this paper, what is happening? These shreds of paper are getting attracted with this balloon. Okay. I hope it's clear. Yes. Yeah, Punyashri, you are right. Okay, very good. Excellent. So let us move next. Now let us understand the theoretical aspects of electric charge. Till now, we have seen three animations. First was not proper actually. First was just an image. We have seen a boy was standing, how his hairs were, like electric hairs kind of. And then we have seen the second experiment in which what was happening. Second experiment mein, the ruler we are bringing near what? The tap water. And how the tap water trajectory was changing. In the third experiment, we have seen what? That if we are rubbing the balloon with woolen fabric, the balloon gains the opposite charges. And when we bring that balloon near what? Near the shreds of paper, what's going to happen? These paper will what? Shreds of paper will get what? Attract with the base of the balloon. Okay. So these were all experimental observations which are connected to the topic electric charge. So since we have seen our experiment, we'll go through the theory. Okay. So we'll understand in this theory of the topic basically, which is electric charge. That is, what is charge basically? What is charge basically? And what are its properties? Okay. Then we'll see the modes of charge transfer. That how the charges can be transferred from one point to another or one place to another via different means. And types of material based on conduction we'll see. Okay. And electroscope. These all things we'll cover in this topic today. So I think we can just cover today electric charge. So we'll not go fast. We'll understand the experiments. We'll see the experiments. We'll build our concepts. Then we'll proceed. Okay. Up to here, is it clear? Write the contents of this subtopic, that is electric charge. Write in your notebook and then reply in the chat box. Students, write in your notebooks and reply in the chat box fast. I'm waiting for your replies. Reply fast, students. Shazan says yes, sir. Very good, Shazan. Excellent. What about other students? Why not attending? Very Shana. And other students? Nobody's here. Shazan is there. Suman is there. Spurti is there. Very good. What about other? They are in the NEET batch or what? So don't want to attend this batch? So when you will come offline, I think then also you don't want, huh? No issues. I'll tell after that. Charges and its properties, modes of charge transfer, type of material based on conduction, electroscope. Written, let us proceed, students. Write step by step all the points, all the theoretical points. Understand the experimental observations, the video and the pictures given to you here, provided on the slides, okay? And keep it noted in your notebook. So next time when you revise the things, it will be very much like a video class, fast forward video class. Next, let us move next. Let us understand charge, that what is charge and its properties. Okay. See, we have studied in the chemistry also that what is the structure of atom. If you take an atom, suppose this is an atom, its central part is known as what? It is known as nucleus. Everybody knows this thing. Nuclei for individual, nucleus, let us say. Nucleus inside in the core part contains what? It contains protons plus neutron. Okay? And we know this thing. Surrounding to this nucleus are the what? Revolving electrons. So electrons are revolving, keeping the nucleus at the center in their respective orbits with different radii. Okay, up to this it is clear. So from where, suppose I have already explained you, suppose this is some neutral atom, so how to make it anion and how to make it cation? Can anybody reply in the chat box? So how to make this neutral atom cation and how to make it anion? Can anybody reply in the chat box? Can any one of you reply in the chat box, students? Reply fast in the chat box. Reply fast. How to make a neutral atom positively charged and how to make it a negatively charged. Very good. One of the students have replied. Sangeeta says to make cation we add electrons. No, cation to matlab positive hota hai, so we have to take the electrons. You are wrong. Okay, somewhat wrong. But you tried it. I appreciate that. To make a cation matlab positively charged atom, we have to remove the electrons. Okay, so let us see it now. See this. Yeah, very good. So you replied again. Yeah, very good. So see now here properly. Nucleus, this is what? Nucleus. These are what? Protons. This is what? Neutrons. So protons and the neutrons, combinedly known as nucleons, are present in what? Nucleus. These are what? Electrons. Okay? So charge on the electron, note it down. It is what? 1.6 10 minus 19 coulomb. We all know this thing, that charge on the electron is how much? It is 1.6 10 minus 19 coulomb. Okay. Charge on the proton, same magnitude, but the charge is not negative here. It is what? It is positive. That is 1.6 10 minus 19 coulomb. Coulomb is the unit of charge. Remember it always. Not all the things, okay? This is what? The unit of charge, coulomb. Coulomb is the SI unit of charge. So suppose we take any neutral atom which contains 11 protons in its nucleus and the same 11 electrons. Count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The nucleus contains 11 protons in its nucleus and the 11 electrons are circulating or revolving around the nucleus, keeping nucleus at the center. Okay. So this is a neutral body scenario. So if you see here, in this, the number of electrons is equals to number of protons. So if you want to create a positive charge, positive atom dominating here, what you will do? The number of protons must be dominating number of electrons. If you want to make it an anion, so what is required? The number of negative charge must dominate this number of positive charge. So how it can happen? It's common sense. Hold on 1 second. See, number of protons, if you see here, number of protons are how much? These are 11 protons. Okay, 11 protons matlab 11 positive charges. These are what? 11 positive charges. Number of electrons are how much? Number of electrons are 11. Okay, so if we take as this body as a complete, number of electrons equals to number of protons, it is neutral. Net charge 0. So this is a sodium atom. We all know this thing, that atomic number of sodium is 11. Okay, it's electrically neutral. So how then we can charge an object, or how does an object get charged basically? How is it? So let us see that. See, this is a chlorine atom. Okay, it is 17 atomic number. We know this thing. Chlorine is having what? Chloride is having what atomic number? 70. So it is having number of electrons as 17 and number of protons as 70. Suppose if I remove, see what is happening. Okay, suppose if I'm if I'm giving this neutral atom via some external agent, the process can be anything: conduction, induction. Uh, we may see that, okay, in the future slides, further slides. So suppose via some external means, via some process, if I give this chloride atom some electron, like this given shown by here with this green color, okay, sphere kind of thing. So this atom has gained electron. So if we count the electrons, number of electrons are how much now? The number of electrons are 18 now. And if we see the number of protons, these are how much? Number of protons are 17 as earlier they were, okay. So number of protons are 17 and number of electrons are 18. So net if we see, the electrons are dominating than protons now. Okay, so more the electrons than the protons. Okay, so we'll say here the body is now negatively charged. So we'll say it is what? It is Cl minus. So you can use the same logic to create the positive if it exists. Okay. So suppose now we can see in the neutral atom number of electrons are 17 and the number of protons are what? Again 17. Okay. So suppose if somehow, see initially the electron was here. If suppose via some external process, by an external agent, I remove this electron out from the outermost shell. Via some external agent, I remove this electron from the outermost shell. So what's going to happen? If I remove this is removed now. So what's going to happen? Initially the protons were 17, electrons were also 17. But now after the removal shown by this loss of electron green color, what is happening now? Number of electrons are now 16. So now the protons are dominating the electrons. Okay. So number of electrons are now 16 and number of protons are now what? These are 17. So we can say more protons than the electrons are. So here you can see that it's written, it's positively charged body. Okay. So this is the process. Very good, Sangeeta. Very good. So what is this? This is the process via which we can charge an atom either positively or what? Negatively. Okay. We can charge atom positively or negatively. Got it? This much written. If you want, you can note it down. So from all this conclusion, including the previous class and today's class, we can say like this: the types of charges are what? There are two types of charges: positively charged, positive charges, and what? There is negative charges. So up to here, note it down. And then reply me in the chat box so we can proceed. We can proceed. Tell your friends to attend the classes. Why not attending? See, it's now online class. It's very easy for the online classes. You just have to keep your mobile phone on, switched on the Zoom platform. And you know the slides are, you have seen now. We have seen experiments, animations, and all these things. So now up to here, note it down, then reply in the chat box fast. Written, very good. Pradeep says written, Abhishek says written. What about Raksha? Noted, very good, Raksha. What about other students? What about other students? Chirag, Dhruva, Spurti, Redmi, Tarun, Varalakshmi. What about you? Vivo, Yogesh, Vishwas. I hope all of you have noted it down. Excellent. I can't say all the names. Whatever is coming in front of me, I'm deciding the name. Okay. Type of charges are completed. Let us move next. Very good. Rohit, very good. Dhruva, very good. Apurva, very good. Excellent. So let us move next. So see, you can see in this pic what is happening. This is a hand of any person. Okay. He or she is what? Holding this cloth. It can be silk, it can be woolen, whatever. The charges on this cloth is, you can see it's neutral. It's positive, negative, positive, negative. Let us see what is happening next. So suppose when I bring a glass rod near to this neutral silk cloth, if I'm rubbing this glass rod, what is happening now?
Negative.
See, hold on. See it properly, then reply in the chat box. Okay. Initially, the charges on this are what? Positive, negative, positive, negative, neutral, positive, negative, neutral, positive, negative, neutral, positive, negative, neutral, upside, positive, negative, neutral. upside down, up positive, negative, neutral, upside positive, negative, neutral, downside positive, negative, negative, neutral. So this complete silk cloth is what? It's neutral here. This is what? This silk cloth is what? CLO. How did the cloth? Cloth is what? Neutral. If I'm bringing a glass rod, which is neutral, which is also neutral. See, hold in. This is also neutral. When I rub with this, what is happening? Some process occurs due to which the negative charges are here, and this rod, which was initially, if you see, this rod, which was initially neutral, positive, negative, when brought closer and rubbed with this neutral silk cloth, it gains a charge which is completely positive. So now this rod becomes positively charged glass rod. This becomes what? Hold on. This becomes what? Positively charged glass. So see, I'm rubbing this neutral rod with the silk cloth. It becomes what? Positively charged glass rod, and that becomes negatively charged on the upside. Okay, that is fine. I hope that is clear. Okay. Now suppose we have seen this in neutral rod when rubbed with the neutral silk cloth. What happens? Positive. Now suppose if I bring the ebonite rod, the rod which is initially the rod is with the glass material. Now I'm bringing a rod with some different material. So when such neutral rod is brought with this cloth, fur, this is not a silk, it's fur. So what happens? It becomes negatively charged while the fur requires amount of positive charge. So you can see the difference, what is happening. Can anybody send me the difference that whatever you have observed from this slide in the chat box? Okay, let me say. Initially, the cloth was what? Cloth was silk cloth. So that silk cloth was what? It was neutral. And the glass rod was also neutral. So when we have rubbed this glass rod with the silk cloth, the silk became negative on the upside and the glass rod became completely positively charged. And now in this process, it is reversed. So what is happening? This ebonite rod, which was initially neutral, and this fur, this is not a silk material. This is some material of the fur. When this ebonite rod is rubbed with this fur material, what is happening? Now this becomes partially negative, dominating negative, you can say, and this becomes completely positive, which is vice versa of the initial case. Okay, this becomes completely positively charged. Okay, so note down both this observation in your notebook because you will find several MCQs in some books where they say what's going to happen if you bring a positive neutral glass rod near a silk cloth, or what's going to happen if you bring even a neutral rod near a fur. So you have to answer all these things. Note it down, okay? Students, please note it down in your chat. In your notebooks, pen, paper, wherever you want. Just at least make a short notes. Next time when you're revising the things, it will be very clear to you. Note it down, students, fast. You have to end the class at 12:15, no? If you have noted, Spurti noted, very good students. See, students who are attending the classes, two cases are there. Remember, students who are not attending these classes, online classes, 100% sure they are enjoying all the days. See, enjoyment is fine. That is for your brain, okay, kind of. But use that enjoyment as a what? As a booster for you, for the education, for studies. You're understanding this thing, okay? So if they're not, at least see, school classes are not going, Avanti classes are going. If you're not attending Avanti classes, then you're wasting your whole day, because at least somehow, if you start from the bio class from the morning, then chemistry, and then ending this physics class, then at the end of the evening, you can just revise the notes, okay? And the morning again start with the bio. At least if you have this kind of routine, you are doing something worth in the holidays at your home. Otherwise, all the day you are sleeping, playing, using the mobile phones, chatting here and there, wasting your time. So do something worth, because if each day you are doing this thing, starting from the bio and physics, and then the evening just little bit revising the notes, coming again in the next class. So how many hours? 4 to 5 hours at least you are studying like this. So each day 4 to 5 hours, this will get add up. And I've explained you in the class on a complex effect. If you want to make a habit, if you want to, at the end, you will see that you have learned a lot of things after 50 days or 40 days. Or you can just analyze this, attend the classes just for 21 days. And after 21 days, you will find this, that you have gained a lot of knowledge just by attending the Avanti class and revising at the evening just for half, 50 minutes or 45 minutes or 30 minutes. It depends upon your speed. Okay. So no, I think you have noted it down. Noted. Very good student. Excellent. So you are these students are attending the classes. It shows that you are concerned about your classes. See, now I'm not teaching here boring things. These sliders are well branded sliders. Okay, fine. Very good, Nandita. Very good, Amruta. Very good. Excellent. Tell your friends, if you are the real friends, tell them that make you don't waste your time, because I know if they're not attending a monthly class, they will not attend any other classes. It's the people who are saying they are having the Byju's tablet. That's a different thing. And you know how much the person have invested thousand rupees in the tablet and how much you're studying. You know this thing. So at least attend the monthly classes, which is like service to you. Okay. So now let us see this one beautiful observation. So what is happening here? Like charges repel each other. So this is a glass rod, which is positively charged. And when I bring other completely positively charged glass rod near this glass rod, what going to happen? So there will be some. See, if the rod was initially hanging, it will get changed. Let us see. Okay, when I have rod this near, its direction changes because this will create a repulsion. So this rod, remember, this rod may get repelled like this. It may move like this. Okay. So repulsion, very good. Sangeeta, very good, excellent. So if we see here, again the same glass rod which is hanging. If I bring this plastic material rod, which is basically completely negatively charged. So these are unlike charges. What's going to happen? If initially the rod was like this, it will get tilt like this. It will get tilt like this because this is attraction here. This is what? This is attraction. This is what? Attraction. Okay. Second case is attraction. First is repulsion. So we can say through this experiment. So students, I'm giving you again and again same things back again. So you can connect the dots back. Okay. That's why I'm giving this. So again and again, when the same things will come in front of your eyes, the concept will go deep inside your brain back. Okay. So these are what like charges repel each other and unlike charges attract each other. Okay. Again, same thing, charge properties. So now we'll note down step by step the properties of the charge. Write the heading properties of the charges. So we can comment here. What we can comment? Like charges repel each other. Oh, students, please mute yourself. Don't do like this. Please don't disturb the class. Okay. I mean, it doesn't look good. Unlike charges attract each other. Okay, like charges repel each other. And what does the unlike charge do? Unlike charge attract each other. I hope it's clear. You have seen this. Okay, answer this question. Ready for the challenge? Students, ready for the challenge? Answer this. Answer this fast. Suppose you are having two charged bodies, A body and B body, which are attracting each other. Now bodies B. So what is happening? A and B are attracting. Then we took this B body and we placed it here in front of a C body. And we have seen this thing that B and C repel each other. So B with the A is having attraction, but same B, same, 100% same, no change. Same B, when kept with the C body, it shows repulsion. So you have to say, what is going to happen if we bring A and C body, if we held them close together, then what's going to happen? Repulsion, attraction, no effect, or information is insufficient. Your time starts now, A, B, C, D. Reply in the chat box, students. What is going to happen? So some of the students have given the answer, very good. What is going to happen? Apurva says A. Varalakshmi says A. Dhruva says attracts. Apurva says sorry B. Reply, students. This is the question for a challenge. It's like a challenge for you. This question is like a challenge for you, students. Reply fast. Sangeeta says C. Okay, let us see. Very easy. It's very easy. One of the easiest questions. Vikas says C. Pradeep says C. Very good, students. Excellent. C. We know this thing. We know the statements. What are the conceptual statements? The conceptual statement says like this. Like charges. The concept says like this. Like charges Like charges does what? Like charges do what? Like charges repel each other. Like charges repel each other. And by the way, what are the set of like charges? The set of like charges are positive, positive. They may be negative, negative. And we say like this: unlike charges attract each other. Unlike charges attract each other. Unlike charges attract each other. And these can be positive, negative, negative, positive. These are same. Just the direction is reversed. Okay. So when A is brought near to the B, what is happening? Attraction. So we say like charges repel. So these are not like. These are 100% unlike. So either A is positive or it is negative. Either if A is positive, B will be negative or B will be positive. Okay. And then we have seen that when B is brought, same B when picked here and dropped here, and when put held close near to the C, what is happening? This is repelling. So we'll say if B is negative, C is negative. If B is positive, C is positive. Okay. And now they're saying A and C when brought near, what's going to happen? So we know this thing. Maharashtra says C. So we know this thing. If A and B are attracting, so jo bhi nature, let us, so in these cases, these are random. So what you will do? You will just suppose one charge perfectly. I will assume that B is negatively charged. So when I have supposed like this, that B is negatively charged, so the case of A to be negative is now omitted. So if B is assumed, supposed initially to be negative, A is positive because these are unlike attraction. So we got from here that B is negative, attractive. Then B is negative, now it's repelling. So C will be like charge. So it is also negative. So we'll say this will be repulsion. So B and C repulsion. So we'll say C is negative now. So A is positive. This will be what? Attraction, because it is asked about A and C. I was saying about B and C. Okay. So A and C, we can say this is what? Attraction. So C is the answer. Very good. Let me see who are the champions. Purva have given right answer. Varalakshmi right. Vikas right. Pradeep right. Sangeeta right. Dhruv attracts. Okay. Very good, students. If I forgot the name, I'm sorry. Okay. We'll see now. Very good. Punishri, it's clear. Very good, students. Okay, if it's clear, so statements theoretical. This is the theory for you. If you want to write in a notebook in the proper sense, I mean, if you can write yourself, that's very good. Otherwise, just follow this. Okay, note it down. So this is a solution for you. Whoever want to note this solution, you can note it down. Otherwise, reply in the chat box so I can proceed next. Otherwise, reply in the chat box, students, so I can proceed next. Please reply in the chat box so I can proceed next. I can proceed next. Written, sir. Saksha says written, sir. Vikas says written, sir. Pradeep says noted, sir. Noted, noted. No, noted, noted. Let's move next. Now we'll see few more additional properties of electric charges. So students, we'll just discuss this slide, then we'll end the class because class timing is what? It's 12:15. I'll launch the NPS after that. Okay. So write the second property, additional property of the charges, that is additivity of charges. Note it down fast. Additivity, just one more slide. I mean this only, not one more. I mean this one more as compared to previous. Additivity of charges. What is this additivity of charges? So suppose I'm having the space, some charges as Q1, Q2, Q3, and Q4. Suppose I enclose these charges in a boundary and give it a name as system. Okay? Now the clear? Q1, Q2, Q3, Q4 charges, enclose them in a boundary and name them system. So we can say the net charge present on this body, in this body, whatever, is how much? It is Q1, Q2, Q3, Q4 ka positive. And remember, students, charges, write this statement that charges are scalar quantity, algebraic. They add like algebra. Very good, Sangeeta. Excellent. So we'll say here charges are scalar quantity. Charges are what? These are scalar. Additive. Charges, these follow additive law, additive properties. Okay. We simply add the changes to get the net charge. They have magnitude but no direction. Very good, Sangeeta. Excellent. So these are not vectors. Vector होते तब direction होता ना. So these are what? These are what? These are simple charges which can be added up like algebra. Okay. So proper signs have to be used while adding this. So see, charges can be positive, negative. Suppose it is negative. So I will write here negative plus Q2 because it's positive, plus Q3 because positive. Minus also to minus Q4. So like algebra, don't think like this negative matlab negative direction. No, charges are scalar quantity. These are algebraic entities. Okay. So can anybody answer? What will be the net sum? Who is the champion? Who is the champion? Answer it. Let us see who is the champion. Fastest answer will be the champion of the 12th class. Let us assume like this. Fastest answer will be the champion of the next upcoming year. Okay, the person who have answered the first chat which came to me is of Spurti. Spurti says minus Spurti says minus Vikas says minus 3. Then so time difference between Spurti and Vikas is 12:13. 1 minute difference. Then all other are same. Bhuvna, Chirag, minus 13. So all are at 12:13. But Spurti is given at 12:12. Okay. So 1 minute before all of you have given, let us count it. So how will add it like algebra? It's like this. Minus 1 plus 2 minus 8 plus 4. That is what? Minus 1 plus 2 plus 1. Plus 4 minus 8 minus 4. Minus dominates. Mathematical. Algebraic. Algebra, mathematics. Minus 3 is the charge. Okay, very good, Spurti. Excellent. So we hope you will be the champion. Other also are like runner-up. Okay. Okay, students. So you got the additivity of the charges. Now let us see the last and then least. I mean, this is the last property. Okay. Then we'll launch the NPS and we'll go. Charge conservation. So as we have seen in the work power energy chapter in the 11th class, that energy remains conserved. It can't be created. I mean, it can't be created, can't be destroyed. Energy is there. The energy is there. So it can be converted from one form to another. Okay. So we will say here that similarly, there is some process which is known as charge conservation, because energy is also scalar quantity. We have seen this thing, which says like this: total charge of an isolated system can neither be created nor destroyed. It always conserved. Okay. So we can say, suppose this is some rod which is negatively charged, and metal sphere is neutral. So if I rub this with this, and finally there is a charge separation, that Q2 is on this and Q1 is on this. So we'll say that after, see, this is the initial process. Metal sphere is neutral. The rod is minus 4 coulomb. And this is the process which is ongoing process. This is which process? Ongoing process. So when I will rub this, what's going to happen? After the finally, what are the charge scenarios? On the rod, the charge is minus 1 coulomb. On the sphere, the charge is minus 3 coulomb. So let us add it. Initially, the total charge in the system, if we consider both of this as a system, it is minus 4 just on the rod. Finally, after the process, if we consider both again, because you have to consider the system as it was. So इस पे अगर minus 1 column है, इस पे minus 3 है, so net charge कितना होगा? Minus 4 column. Okay. So total charge remains conserved here. Remains. Write the statement. Total charge of an isolated system can neither be created nor destroyed. It remains conserved. Initially it was minus 4, finally minus 4. Understood? If it's understood, reply in the chat box. We can lose the NPs then. Students, if it's understood, reply in the chat box, then we can lose the NPs fast. Pradeep, reply. Sangeeta, reply. Spurti, all the. Spurti, tell your friends, okay, to attend the classes. Otherwise, I know they are not doing anything. You ask from them, what are you doing in the physics? And you tell them the classes are fine. Branded slides, no. Online material, what to tension? Nobody is scolding here. Okay, students, my dear prospective students, I am launching here NPS poll for you. I have launched the NPS poll. Students, please participate in this. Please participate. Give your views, proper views as per today's session. Okay. How you felt? If you want to give additional feedbacks, you can put this in the chat box. I will add this because see, we started with the animation, all this. Okay. Now, Apurva, are you having any doubt, or anybody is having any doubt? I can separately explain that doubt on the whiteboard, and rest of the students can leave after this NPS poll, after they have attended the NPS poll. Okay. I hope it's clear. I hope it's clear, students. So bye bye everyone and be happy. Okay. I mean, we'll meet in the next class. Got it. We'll do what? We'll meet in the next class. Fine. I hope it's clear to all of you. I hope it's clear to all of you. All of you students, all of you students. Okay, students. So best of luck. Work hard, study smart, work hard, work smart, whatever. Just be smart and work hard. Okay, fine. So, you're done? Attended all? Okay, Spurti. Bye, Bhuvna. Bye, Purva. Bye, everyone. Study well. I hope that you have attended this poll perfectly. Okay, all of you have attended. Bye, Raksha. Bye, everyone.